Have you ever found yourself pondering the inner workings of the Pythagorean theorem? This ancient piece of wisdom, named after the Greek philosopher Pythagoras, has been a cornerstone of geometry for over 2,000 years. Today, we delve into the heart of this theorem and unravel the proof that underpins it. Firstly, let's demystify what the Pythagorean theorem actually states. Remember those right-angled triangles from your math classes? The theorem applies specifically to them. It says that in a right-angled triangle, the square of the length of the hypotenuse, the side opposite the right angle, equals the sum of the squares of the lengths of the other two sides. Now imagine a square, each side of which is the length of the hypotenuse. Inside this square, place 4 right-angled triangles, each identical to the original one. At the center of the square, you will see another smaller square, formed by the remaining spaces. The area of the large square equals the sum of the areas of the 4 triangles and the small square. However, the area of the large square also equals the square of the hypotenuse. Therefore, the square of the hypotenuse equals the sum of the areas of the 4 triangles and the small square. Now, take a look at the smaller square. Its sides equal the difference in length between the 2 sides of the triangle. Thus, the area of the smaller square equals the difference of the squares of the 2 sides of the triangle. But wait, those 4 triangles, they're identical, right? So, the total area of those 4 triangles equals double the sum of the areas of 2 triangles, which equals double the sum of the squares of the 2 sides of the triangle. Bring these 2 insights together, and voila! The square of the hypotenuse equals the sum of the squares of the other 2 sides. That's the Pythagorean theorem. To summarize, the Pythagorean theorem states that in a right-angled triangle, the square of the length of the hypotenuse equals the sum of the squares of the lengths of the other 2 sides. The proof of this theorem involves visualizing a square built on each side of the triangle, demonstrating that the area of the square built on the hypotenuse equals the combined areas of the squares built on the other 2 sides. So, the next time you see a right-angled triangle, you'll know exactly why the Pythagorean theorem holds true. It's a testament to the enduring power of mathematical proof and the elegance of geometric shapes. It's not just a theorem, it's a window into the beautiful symmetry of the universe.